Hello, welcome to session 5. In this session, we are going to have some extended discussion about implementing a state machine in LabVIEW. So we have this state machine implemented from session 4. So when there is some change in the sensor simulator value, you can see that change appears in the chart, and when there is no change, the chart will not update. Also, I have a clear button here, so when I click clear, chart will be clear, and also any change in this sensor value appears in the chart. That's the behavior of state machine we implemented in session 4. As I mentioned in session 4, we have this timeout for the event structure. I put the timeout value into 1 millisecond. If I put it into, for example, 10 seconds, you can see the loop counter 1 and loop counter 2. The loop counter 1 is the indicator inside the while loop, and the loop counter 2 is indicator inside the timeout. And the loop counter 1 is always one number ahead of loop counter 2. That is because of the timeout. The timeout session is here for the event structure, so the whole program stays here until the timeout happens. So if there is no timeout, I can put that value into -1, so it's infinite. None of loop 1 and loop counter 1 and loop counter 2 will update anymore. What happens now if I change sensor value? If I change sensor value, you can see that the chart will update and loop counter 1 will update, but the loop counter 2 won't update anymore. This is the pure event-driven system. They also call it reactive system. There is no action or no activity in the system until you give it a request. So the system reacts to your request. Sometimes we had to have the event-driven system with the time trigger system together in one system. In that case, we had to put that timeout something less than infinite. Okay, but now if I change this timeout again into 1 millisecond, it doesn't work because the program is here. It doesn't check your timeout to be updated. So you had to break it and restart it again. Okay, uh, this is something about the state machine, which is the ideal state machine is something that it's purely event driven, and we sometimes need to have a time trigger structure inside that purely event driven system. So another thing that if we want to extend the state machine, if we want to have more state, what can we do? Here we implement this state machine with a constant enums. When there are constant enum, they're independent. So if you add some, for example, items to this state, that this enum won't update. So what can we do? If I change this constant enum into something like control, there's also another limitation. Let me show you. When I put a control enum here, you can see that the value of the control enum appears in the front panel, and you can see it here in the block diagram. So it's something that you can easily work with it. Okay, what is the solution for having the constant enum? connected to each other, you have to right click on your enum and into advanced and customize, you have to make a type definition of your enum. So here in control, you can click on the type definition, so it will be a type definition, and in other place in your program you just can put another enum with that type, so they're somehow connected to each other, they're not separate. Okay, right click here, edit item, I can put a new state here. Okay, I have to save this type definition. For example, I save it like state type. I also can put ENU state type. So saved. Yeah. Uh, okay, this is the constant, with the ENU state type. So whenever in other place in my program, I click and create constant from it. See what is the difference between two constants. This constant will not update. I don't have the new state, but then this one will update. So if I go again into my type definition and add another item, you can see here that the new state2 appears here. So how can I put it into my case structure? In case structure, you can easily go to update chart and right click and add the case after. It automatically adds new state. For another one, again, new state 2. So today I discussed two facts about implementing and developing a state machine in LabVIEW. The first one was timeout. If you put that timeout into -1, it will become a purely event-driven system, purely reactive system. But if you want to have time trailer system beside your event-driven system, in some application you need that. For example, checking some input in pooling way. So you had to put in something less than infinite. Okay, and another thing I discuss here, if you want to dynamically add a new state to your state machine, you have to have this constant connected to each other. By default, they are not connected; they are separated. To be able to have them connected to each other, you have to make them a type definition. So whenever in your program you have constant, with that type, uh, it will be updated automatically. Okay, let's see you in next session. Thank you.